Now, yesterday we solved this particular equation, but we put the equal to 11 and then we solve the less than 11. So let's say you just get given this question only, just like that. We're going to solve that. We know that this would be the cases method, right? So we're going to solve this equation straight up with the less than 11, all right? So our first case, so cases again, let's look at our critical points and what have we got? No. 1, 3, and 4. So, no, just looking here, I've got 3/4 and 1. So what I'm going to do, I'm going to solve this equation. Yesterday we solved it with equals 11, and then we tested points to do the less than 11 scenario. What we're going to do here is just solve it all in one step with the cases without having to check points in between and things like that. All right? So you can solve this just straight off like that. So remember, we've got the critical points are 3/4 and 1. We've got region 1, region 2, and region 3. So case 1 would be x is... Now, I'm going to use... See how this equation's just got a less than? I'm going to use less than. Oh, less than 3/4. Okay. I'll do less than or equal to. Less than or equal to 3/4. So with the first one, so for example, 0, if x was, or t. So if t was 0, would this be positive or negative? What have we got? Negative and negative. So we would go negative bracket 4t minus 3 minus t minus 1 is less than 11. Notice I'm doing with the less than in there, okay? Yesterday we did equals 11, and then we did part B where we looked at where it was less than, okay? So we've got minus 4t plus 3 minus t plus 1 is less than 11, minus 5t plus 4, so this would be 11 minus 4, minus 5t is less than 7, and so therefore t is what? What do I do now? Flip. Because it's greater than 7 divided, because I'm dividing by -5. Now, is there an intersection between these two solutions? This is telling me this will only work for values of t less than or equal to 3/4, and I've got t is greater than -1 and 2/5. There is an intersection between -1 and 2/5 and 3/4. So, my case 1 tells me I want values of t less than or equal to 3/4, right? And my value here, my solution is saying that t is greater than -1 and 2/5. So my solution is between there and there so far. Because I'm allowed to have anything from here downwards. And my solution here is saying t is greater than 1 and 2/5. So the intersection is between those two bits. So far, I've got that t, do you see that? T is allowed to be less than or equal to 3/4, and I've got t is greater than -1 and 2/5. So I'm allowed to go from -1 and 2/5 up to 3/4. So this is the solution I'm getting. This is the case is saying we only want solutions in this domain, or for these values of t. So the intersection between those two is there. So far, I've got from -1 and 2/5 up to 3/4, and including 3/4. I'm going to do case 2. So I need to do my cases, and then I'm going to make my conclusion. All right. So case 2 is between 3/4 and 1. So remember, I think yesterday we looked at 7/8 or something. So 7/8. If I had 7/8, what have I got? Is this positive? I think that's negative. No? Someone do it, please. 7/8. That's 7/2. That's 3.5. Oh no, that's positive. That one's positive. This one's negative. So we've got positive. So 4t minus 3 minus bracket t minus 1 is less than 11. 4t minus 3 minus t plus 1 is less than 11. 14, so 3t minus 2. So it would be 11 plus 2. So that would be 3t minus 2. I probably should put it. We don't want to make mistakes. 3t is less than, what have I got? 13? Yep. See how I made the mistake of 9? And t is less than 13/3. Now, this method is tricky, but This is telling, no, t is less than 13 over 3, meaning that t could be between, is less than 3 and a third. So this is telling me that t is less than 13 over 3. But this is saying I only want values of t between 3/4 and 1. So 3/4 and 1 are in here. So that means all the values between 3/4 and 1 are included. Do you sort of get that? I can't do, so t is less than 13 over 3 is not the solution. So I want all these values, but my case says I only want values between 3/4 and 1. There is an overlap. So far I've got between -1 and 2/5 and 1. Because I've got between -1 and 2/5 and 3/4. And here I've got between 3/4 and 1. Bit confusing. I'll draw it all out in a diagram in a minute. Case 3 is t greater than or equal to 1. And I think we get positive for both those. T greater than or equal to 1. I believe, yes, we get positive scenarios for, if t was 2, that would be positive, that would be positive. So they're both positive, so we've got 4t minus 3 plus t minus 1 is less than 11. So we've got 5t minus 4 is less than 11, 5t is less than 15, t is less than 3. Now, sorry. So t is less than 3. So this is allowing me to have values of t greater than or equal to 1. And here I've got t is less than 3. So if, do you know what the overlap is, guys? If this is telling me t is greater than or equal to 1, and here in my solution I've got t is less than 3, the overlap is between 1 and 3. Okay, let's look at all our answers. So this is case 1 wants values of t less than or equal to 3/4, and I've got t is greater than 1 and 2/5. So here is t is greater than 1 and 2/5. Here is t is less than or equal to 3/4. The overlap is between -1 and 2/5 and 3/4. Then in the second case, I want values of t between 3/4 and 1. So between there and there. But my solution says t is less than 13 over 3. So it's all of these values. So there is the overlap here. So t is also between 3/4 and 1. And in my final case, I want values of t greater than or equal to 1. So I want anything like that. But my solution is t is less than 3. I do have an overlap between 1 and 3 of these two values. So therefore t lies between -1 and 2/5 and 3. No? Yes? Solving another absolute value equation. Okay, what are our critical points? I know we've got 2. I know one's on one side, one's on the other. I'd be very careful with doing plus plus and a plus minus because you've got this 3 here. The only time you do plus 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 minus would be perhaps if that 2 wasn't there and that 3. If you had absolute value of x equals absolute value of x minus 1, but we've got that 3 there. I wouldn't be doing plus 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 minus. I would be doing cases for this because this really is like an equation. Okay, now I could put everything over this absolute value of x minus 1 to the left if I wanted and solve it that way if I wanted, or I can just look at what I think my critical points are going to be here. What are they going to be?
0.
Yeah, you've got 0 and 1. So they're your critical points. Remember, see that equation there? It really is just this, watching. So I'm going to rearrange that. Isn't that just this? If I put that absolute value over to the left, and you can see why I need to use the cases method. If I rearrange this and instead of plus the absolute value of x minus 1, I take that over. It really is just, now you can see that you would need cases. Do you understand? All right. So that is just the same as that. So we're going to use cases, region 1, region 2, region 3. First case is for x less than or equal to 0, case 1. Okay, we'll use the bottom equation. We don't have to use the top one. If x was negative, what would happen here? What do I put? 2 times negative x. Don't I put a negative in front of that? So I'm going to write it as negative 2x equals 3. Now, if x was less than 0, say if x was negative 1, would this be positive or negative, this absolute value of x minus 1? Negative. So I go minus bracket x minus 1. So if x was less than 0, less than or equal to 0, for example, if x was negative 1, I'd put the negative in front of that and the negative in, the negative in front of that and the negative in front of this. Okay, so I've got negative 2x equals 3 minus x plus 3. I'm going to put my x's on the left, actually. So I've got x equals plus 1, that's right. Geez, 3 plus 1 is 4. X is negative 4. Is that what we got? X is negative 4. So x is negative 4. Does that lie within the region x is less than or equal to 0? So this is x is negative 4 is a solution. Okay. Next, case 2. X lies between 0 and 1. What are we going to go for? A half? Let's say x was a half. Would this first one be positive or negative? Positive. If x was a half minus 1 is negative, so that this one would be negative. So this time we've got positive and negative. So we've got 2x equals 3 minus bracket x minus 1. So I've got 2x equals 3 minus x plus 1. And I've got 3x equals 4. X is 3/4. Is that a solution? Tell me no, I did it wrong, didn't I? My goodness, it's 4 over 3, which is 1. I don't know what's wrong with me, which is 1 1/3. Is that within that solution? This is not a solution. Okay, good. And number 3, case would be x greater than or equal to 1. Let's have a look. I think they're both. What do you think? This one's positive. Say if x is 2, this one's positive. So it's the plus plus. So we've got 2 times x equals 3 plus x minus 1. So I've got x is 2. Is that allowed? X has to be greater than or equal to 1, and I'm getting x is 2. Is that a solution? Good. So x equals 2 is a solution. So our solutions are x is 2 and negative 4. Now, let me now do the inequality. So what I'm going to do, I think it's easier if we've got the inequality to do the equal, if you ask me. Much easier. All right, so what we're going to do, we're going to solve 2 inequalities. We're going to solve the following. So hence we're going to solve this. 2 times the absolute value of x is greater than 3 plus the absolute value of x minus 1. Let's solve that. So we know when it's equal, my solutions are negative 4 and 2 when it's equal to, right? You know how we just did the equal scenario? My solutions were negative 4 and 2. So what we're going to do, either we've got solution here, here, here. I have to test 3 regions now to see where the inequality solution lies. See, I've got the solution for equals. But now if this was an inequality, for example, greater than, I now want to see where my solution lies. So I know the equal to solutions are at negative 4 and 2. I need to see where the inequality solutions are. So I'm going to go region 1, region 2, region 3, and I'm just going to test. Let's say x was negative 5. So testing in region 1, I'm going to try x is negative 5 because I have to pick a value less than negative 4. Do you get that? So what would I get here? 2 times absolute value of negative 5 is greater than 3 plus absolute value of negative 5 minus 1. Isn't that just 2 times 5 is 10? Is greater than. This is negative 6. Absolute value of negative 6 is 6. 3 plus 6 is 9. That's true? Okay. So x equals, x is less than negative 4 is a solution. I use less than because I've got a greater than symbol here. So this is true. So I know in region 1, I've got x is less than negative 4. I tried negative 5 and it worked. So I know x is less than negative 4 is a solution, right? So therefore I can say x is less than negative 4 so far. Let me try region 2. Region 2 lies between negative 4 and 2. Choose a value. 0 is lovely to choose. So I'm going to try x is 0. So I'm just going to try. So region 2 is between -4 and 2. Try x is 0. I get 2 times absolute value of 0 is greater than 3 plus absolute value of 0 minus 1. 0 is greater than 4. Not true. So therefore, between -4 and 2 is not a solution to this inequality. And then in my last area, x is greater than 2. Let's just try what? Try x is 3. 2 times absolute value of 3 is greater than 3 plus absolute value of 3 minus 1. 6 is greater than 3 plus 2, 5. True. So, therefore, x is greater than 2. They're my two solutions. X is less than -4, x is greater than 2. All right? Now, I could have also solved to absolute value of x is less than, and then this middle one would have worked and been the only solution. Okay, so if you've got the inequality type at the moment, I would do the equal scenario, plot my equal to solutions on a number line, because remember, when it's an inequality solution, you don't want just one value of x in your answer. You need a range of values. Okay?
For the x is...
In region 1, it is any values of x less than -4, so I tried x is -5. But the region is the x is less than -4. In the second one, the region that I want to try is from -4 to 2, so I tried x is 0. And in the last region, x has to be any value greater than 2. I tried x is greater than 3. X equals 3. And I found that it worked. So as long as you're testing a value in that region, if it works, then that domain there is a solution. All right, so here I can just put my first region was x is less than -4. This one was x is greater than 2. And this one was from -4 to 2. Okay, so I'm trying values in those regions or in those domains. All right.